Hello everyone and welcome back to the channel. Reversing a string sounds simple, right? But there is a wrong way most developers reach for first and a clean open space solution. That's what interviewers actually want to see. I'm going to show you both why the obvious approach falls short and then the two-pointer technique that solves it in place. Let's get into it. The problem is given a string as a char array, reverse it in place. So hello becomes a reversed hello. Now notice the constraint. The problem says explicitly in place, order of one extra memory. That rules out creating a new array or most built-in utilities. And that constraint is actually what makes this interesting. Let's first take a look at what you can't do and why. Let's start with the first instinct for a lot of developer, creating a copy, making a new array and filling it in reverse order. Let me show you. Straightforward logic. We create a copy array and loop from the end of original array. Why end? Because from the end we will keep copying the character to our copy array. Basically, the last character comes to the first index of our copy array, which is O. Similarly, our pointer moves left to L. We copy L to the first index, then copy the second L to second index, then E to third index, and then H to last. But here's the issue. What does the problem say? We should be doing it in constant space. The moment you create a copy array, you have used ON space. That's instant disqualification. We did it here just for better understanding and why it fails and what makes the two-pointer solution click. And this is important lesson. Always read the constraints before you write a single line. Constant space is right there in the problem. The copy approach is the first thing most people think of. The interviewer knows that. They put the constraint there specifically to push you past it. So what's the solution that actually satisfies constant space requirement? We would be using a two-pointer approach here. Constant space means no new array, no copies. You have to work through whatever you are given, the original array itself, nothing extra. That's exactly the thinking the two-pointer pattern is built for. Okay, now let's talk about the two pointers. Here's the idea before we write any code. We place a pointer at the start of the array and another pointer at the end. We go on and swap these two elements in place. And after swapping, we move the left pointer to the next and right pointer to left. Repeat it until they meet in the middle. That's it. No extra array, just swapping elements in place. Let's trace through our example. Array is hello and our left is at 0, right is at the end, which is 4. We swap our left and right. So H becomes O, O becomes H. Once these are swapped, left moves to the right, right moves to the left. Our left index is now at index 1 and right index is at index 3. Once again, we swap these two. So E becomes L and L becomes E. Once again, left moves ahead, right moves to the left. Now we check at this point, both pointers are at same place, so we don't need to swap anything. At this point, our output array has become reverse of the original array. So I will write it clearly. This is our original array changed in place. So the overall idea is we start with two pointers left and right. At every iteration, we swap these two. Once left and right meet in the middle, we stop. String is reversed. Now let's write it. We start by declaring left and right, our two pointers, both at each end of the array. And keep going while left is less than right. Do a simple swap on the array with left and right. Then left increases, right decreases as we discussed. Let me quickly write the function for swap as well. It will take an array and a left and a right. It will simply have a temporary character where we will assign our left value, and then left will have the right value, right will be temp. So this is a simple swap function. Let's try running it. All right, it's accepted, and if I submit, it passed all the test cases and beats 100%. So that's good. Let's do a time and space complexity analysis before we wrap up. So the time complexity here is order of n. We are visiting every element once, and space complexity is order of 1. It's constant time because we only have one extra variable and all the things are done in place. Comparing that to the copy approach that we discussed earlier, we have same time complexity, order of n, but the space is down from order of n to order of 1. No extra array, only one extra variable. And notice left is less than right. When both pointers are on the same middle element, there is no need to swap. Even if you have equals to here, that would be fine. This condition handles both even and odd length arrays correctly. There are many other problems which follows this exact structure, left and right converging inwards. It can solve palindrome check, container with most water, trapping rainwater, threesome, and dozens more. I would suggest you to try those as well. Learn this movement, not just the problem. Now, there is actually another way to solve this using recursion. It's a great exercise for understanding the call stack and the base cases. If you want me to cover the recursive approach, drop a comment below and I will include it in a future video. Let's wrap this up with the comparison you actually need. Two pointer every time in place, order of one space, clean and readable. If an interviewer asks you to reverse an array and you write two pointer without being prompted, that's the signal. It says you understand memory, you understand iterations, and you know your data structures. And notice this is one of the rare LeetCode problems that tells you exactly what algorithm to use. Reading constraints carefully is half the interview. That's the three ways to reverse an array: the lazy way, the right way, and the recursive way. One pattern in this video, two pointers converging inward, is going to come up again and again as we go deeper into this series. If you missed video 1 on twosome and the hash map pattern, that's linked on the screen now. Same idea of understanding the pattern, not just the solution. If this was useful, subscribe. New video every week. See you in the next one.